One of the methods that the team used to understand this problem was the creation of a house of quality. In the house of quality, we assigned the weights for the customer requirements based on the number of points we will gain if we successfully fulfill them. Requirements which could result in disqualification were given much higher weights, as failing these would result in forfeiting the match. For example, passing the go-no-go box inspection was given a 9, as failing this requirement would result in disqualification. Using the relationship matrix, we identified that the range of the Dementor remover was the most important engineering requirement, followed by the number of parts in the final assembly. This suggests that our team should prioritize removing the Dementors and keeping the mechanisms as simple as possible. The two engineering requirements related to placing Grindelwald in Azkaban, the time to place Grindelwald, and the repeatability of the Grindelwald placing mechanism received some of the lowest relative importance ratings, suggesting that these tasks should be a low priority in the design phase.
The specification sheet lists the requirements needed for the machine to score as many points as possible. These specifications are derived from the requirements generated in the House of Quality. We selected the most important specifications, which are geometry, energy, schedule, and rule compliance, as these specifications were needed or else the machine could be disqualified. The geometry is needed because the machine must fit in the go-no-go box or else the machine would not be able to compete. The energy source is important because only this type will be provided to the machine during the competition. The machine must fit a tight schedule for completing tasks, all while being completely autonomous. And finally, the robot must comply with additional rules, such as triggering every time, to be considered for scoring points.
A function tree diagram was created to determine the functions that the mechanism must accomplish. The primary function is to score as many points as possible in the final competition. Many of the subfunctions listed apply to many of the different tasks. For example, for each of the competition tasks, the mechanism must navigate to specific locations and apply different types of forces to the objects on the playing field. For this reason, the team identified these two functions as being some of the most important ones to focus on during the design process. In addition, the team identified detecting the wall dropping to be one of the most challenging tasks. Because of this, the team expects that during the design process, imprisoning Grindelwald will prove to be the most difficult subsystem to make.
The morphological chart displays possible design alternatives for the specific functions derived from the function tree. Given that the navigate to specific location and apply force sections include the most amount of design options, they will allow for the most amount of combined designs. The final combinations will include the best features of the best designs. For example, within the apply force category, there are many different design options to complete the Niffler and shiny object task. This includes a spiral conveyor belt, a net with holes, and a rail system to sort through the different objects.
The planning tree diagram shows the tasks that must be accomplished in order to create the final competition robot. This main task is broken down into 5 separate tasks, which includes project planning steps as well as design steps. Within the project planning section, there are many steps that must be taken in order to ensure that the team is ready to move on to the design process. This includes making a variety of planning charts, researching existing systems, and using CAD to create models of potential designs. Once the team has determined which design to proceed with, each subsystem can be created and tested.
The Gantt chart provides a general outline for when our team expects to complete each task. This chart also encourages us to stay on top of the extremely fast-paced timeline. For example, after consulting the Gantt chart, our group realized that we need to complete the planning report by week 8 in order to be able to start creating subsystems by week 9.
A prioritization matrix detailing the design team's required tasks better focuses the attention of the group to the tasks that are more pertinent than others. Looking at the prioritization matrix, the tasks were listed in chronological order to better understand at what point in the design phase the important tasks are clustered in. This helps the team prepare for this increased demand and focus. Looking at the most important tasks in the prioritization matrix, assembling and testing subsystems in the final system are the most important tasks in the matrix. This allows the team to plan to accommodate the increased workload necessary to complete these tasks. This part of the matrix also shows that the last few tasks in the list are the most important based on the amount of pluses in that area.
The job responsibility matrix is a planning tool used for delegating responsibilities to team members to give accountability and jobs that suit each member. The responsibilities are pulled from the prioritization matrix and assigned to each team member, who will be able to complete the task with the highest quality relative to the group. The matrix also helps bring together what each member should be able to present when judged at the final competition.